Welcome to Math Tutorials. In this video, we are solving every question of the miscellaneous exercise on Chapter 7, Integrals, from the NCERT Mathematics textbook for Class 12, Part 2. The miscellaneous exercise on Chapter 7 is the longest of the book. 40 questions sweeping every technique of integration, 23 indefinite, 8 definite, 6 proofs, and 3 multiple choice. Here is the full list, grouped. Question 1 of the grand integrals miscellaneous. Factor the cubic denominator fully. 3 linear factors, 3 cover-ups, x times 1 minus x times 1 plus x. The constants are 1, 1/2 minus 1/2. Combine the logs into one compact expression. Question 2. Rationalize the sum of roots. The difference of the arguments appears below. Multiply by the conjugate. The denominator becomes a minus b. Integrate each root with the power rule. Question 3. The hinted reciprocal substitution x equals O over t. The root simplifies dramatically. With x as O over t, the algebra collapses the integrand to a power of t over root t minus 1. Twice the root back in x. Question 4. Pull x to the fourth out of the bracket. 1 plus x to the minus 4 becomes the substitution. Factoring makes the integrand x to the minus 5 times the shifted bracket. T as 1 plus x to the minus 4 gives dt with minus 4x to the minus 5. Back in x. Question 5. The hinted x equals t to the sixth clears both fractional powers. A polynomial division in t follows. The substitution gives 6t cubed over t plus 1, which divides out. Integrate and restore the sixth roots. Question 6. A linear and an irreducible quadratic below. 3 constants to match. The decomposition gives minus 1/2, 1/2 x, and 9 halves. Log, half log, and arctangent over 3. Question 7. Shift the variable to center on the denominator. T is x minus a. Expanding sign of t, plus a splits into cosine, a plus sign a cotangent t. Integrate, t cosine a plus sign a log sign t, back in x. Question 8. E to the log powers are just powers of x. The fraction telescopes. The numerator is x to the fifth minus x to the fourth. The denominator x cubed minus x squared. Everything cancels to x squared. A one-line integral. Question 9. Cosine feeds sine under an inverse sine root. T is sine x. The integral becomes the standard inverse sine with a equal to 2. Back in x. Question 10. The 8th powers factor as a difference of 4th power squares. The denominator is exactly one of the factors. The numerator factors into sine 4th minus cosine 4th times sine 4th plus cosine 4th. The second factor equals the denominator, and the first is minus cosine 2x. Integrate the cosine. Question 11. The two-shifted cosine trick with plus signs. Multiply by sine of a minus b. Expanding sine of the difference of the two angles splits the fraction into two tangents. Integrate to the log ratio of cosines. Question 12. X cubed is a quarter of the derivative of x to the fourth. Inverse sine of the fourth power. T is x to the fourth. Back in x. Question 13. E to the x is its own derivative, substituted away. Partial fractions in t. T as e to the x gives the two-factor split. The log ratio in e to the x. Question 14. Two irreducible quadratics split as if in x squared. 1/3 of the difference of reciprocals. The decomposition in x squared gives a third of each reciprocal difference. Two arctangents. Question 15. E to the log sign is just sine. An odd cosine power with sine. Substitute cosine. The integrand is cosine cubed sine x. U as cosine. Minus a quarter of the fourth power. Question 16. E to the 3 log x is x cubed. The log pattern with x to the fourth. X cubed over x to the fourth plus 1. A quarter of the derivative over the function. A quarter log. Question 17. Fully abstract, the power rule through a linear inner function. U is f of a x plus b. Du is a f prime dx, so the integral is a power integral over a. Back in the abstract notation. Question 18. Expand the shifted sign and factor sign forth from the root. Cotangent becomes the substitution. The root becomes sine squared times root of cosine alpha plus cotangent x sine alpha. T, as that bracket, has dt with minus cosecant squared sine alpha. Minus 2 roots over sine alpha. Question 19. Multiply inside by 1 minus x to rationalize. The root of 1 minus x squared appears below. The integrand becomes 1 minus x over the root of 1 minus x squared. 2 standard pieces. Inverse sine plus the root. Question 20. The e to the 2x version of the f plus f prime pattern. Half angles reduce the fraction. The fraction is half secant squared plus tangent. With f as half tangent, this is f prime plus 2f, matching the e to the 2x pattern. The pattern gives e to the 2x times f. Question 21. A repeated factor and a simple one. 3 constants, minus 2, 1, 3. The decomposition. 2 logs and a reciprocal. Question 22. The substitution x equals cosine 2 theta collapses the root. Half inverse cosine emerges. With x as cosine 2 theta, the root is tangent theta, so the integrand is theta. Half inverse cosine of x. Integrate half inverse cosine by parts. Question 23. The last indefinite integral. The log difference is log of 1 plus 1 over x squared. That same bracket becomes the substitution. With t as 1 plus 1 over x squared, the whole integrand reorganizes into minus half root t log t dt, integrated by parts. Package the result in the book's factored form. Question 24, first definite. Half angles expose the e to the x pattern. F is minus cotangent of half x. The fraction is half cosecant squared minus cotangent of half x. F prime plus f with f as minus cotangent half x. Cotangent of pi over 2 is 0, of pi over 4 is 1. Question 25. Divide by cosine fourth and substitute tangent squared. An arctangent of u appears. With u as tangent squared x, the integral is half the arctangent integrand from 0 to 1. Pi over 8. Question 26. Rewrite the denominator and split off a constant multiple. The tangent substitution finishes it. The denominator is 1 plus 3 sine squared. Standard manipulation with tangent gives the arctangent of 2 tangent x. Partial fractions in t squared, and the 2 arctangent limits give pi over 6. Question 27. Sine 2x is 1 minus sine minus cosine squared. The numerator is the derivative of sine minus cosine. With t as sine minus cosine, the root becomes root 1 minus t squared. The symmetric limits give twice 1 arcsine. Question 28. Rationalize the difference of roots. The conjugate sum integrates directly. Multiplying by the conjugate leaves root 1 plus x plus root x. Evaluate 4 root 2 over 3. Question 29. The same t as sine minus cosine, now inside a rational function, 25 minus 16t squared below. Sine 2x is 1 minus t squared, so the denominator becomes 25 minus 16t squared, with limits minus 1 to 0. Log 1 minus log 1/9, log 3 over 20. Question 30. Substitute sine, then integrate by parts. U as sine x doubles into 2u arctangent u. The substitution gives 2u arctangent u from 0 to 1. Parts leaves the split fraction. Pi over 4 minus 1 minus pi over 4. Pi over 2 minus 1. Question 31, the last evaluation. 3 moduli, 3 corner splits. Handle each modulus separately over 1 to 4. The 3 integrals evaluate to 9 halves, 5 halves, and 5 halves. Sum 19 halves. Question 32, first proof. Partial fractions with the repeated x. 3 pieces, minus log, reciprocal plus log. The decomposition and its antiderivative. Evaluate the claimed 2/3 plus log 2/3. Question 33. The parts classic on the unit interval, x minus 1 times e to the x, the antiderivative, and the endpoint values. Exactly 1. Question 34. Odd times even on a symmetric interval. No computation at all. X to the 17th is odd, cosine 4th is even, the product is odd. An odd function over minus 1 to 1 integrates to 0. Question 35. Peel one sine and substitute cosine. A cubic in U. Sine cubed is 1 minus cosine squared times sine. 0 minus 1 plus a third, 2/3. Question 36. Strip tangent squared into secant squared minus 1. Tangent squared and log cosine. The identity split and antiderivative. 1 plus 2 log of 1 over root 2. 1 minus log 2. Question 37, the last proof. Parts with 1. X arc sine plus the root, the antiderivative of inverse sine. Pi over 2 minus 1. Question 38, multiple choice. Multiply through by e to the x. An arctangent of the exponential appears. With t as e to the x, the integral is dt over 1 plus t squared. Arctangent of e to the x. Option A. Question 39, multiple choice. Factor cosine 2x. One factor cancels, leaving the log form. Cosine 2x is cosine minus sine times cosine plus sine, so the integrand reduces to the derivative over function form. Log of sine plus cosine. Option B. Question 40, the final question of Chapter 7. The abstract king property. Reflect and add, as always, reflecting x to a plus b minus x and adding the two forms of I. 2I is a plus b times the plane f integral. Option D. That completes the miscellaneous exercise, and with it the whole of Chapter 7, Integrals, the longest chapter of Class 12. In the next video we begin Chapter 8, Applications of Integrals. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.